if there are any long-term volunteers who are on this call, you recognize these bottles. These are the bottles that we send from the Eagle Laboratories to all of you. And we essentially what's the simple protocol is that we go out to the deepest part of the lake at two different times of the year, or you can choose one or two times, and you are sampling a surface water sample, and then we send it back to Eagle and they analyze it for total phosphorus. So phosphorus is a really important nutrient in our water systems. It's key for primary productivity, and what we mean by that is algae and plant growth. It's found in all waters. It's just naturally high in some and naturally lower in others. What we find is algae and aquatic plants need a host of nutrients to live, grow, and reproduce, just like us. And phosphorus in many of our waters, not all of them, in many of the waters, is the limiting nutrient. And what we mean by that is all other nutrients are there in a good abundance. And if we add more phosphorus, then growth occurs. And so that is our limiting nutrient. Now, again, it's essential, an essential part of our lake ecosystems, but different development, different activities on the shoreline and in the watershed can release excess phosphorus, and this can cause problems. And if this excess phosphorus is caused by human activities, we call it cultural eutrophication. This can result in higher algal biomass and possibly HABs. HABs is short for harmful algal blooms, also known as cyanobacteria or blue-green algae that produce toxins in the water. It can reduce the aesthetics. I hope none of our lakes ever look like this, but this might be a problem if you want to go swimming or just enjoy the lake. When there's all this growth of algae on the surface or near the surface of the water, there's also a lot of death. As the algae live, they die, they fall towards the bottom. Decomposers will decompose that, and that process uses oxygen, and so you can actually have increased chances of anoxia. And then we've also seen studies that you can have reduced economic value. And this is now a very famous image that shows a harmful algal blooming in Lake Erie. This image is coming from a lot of work that's being done in the watershed of Lake Erie and within Lake Erie itself to show how caused by the Toledo water crisis, where they had to shut down Toledo's water intake from Lake Erie because there were toxins in it from a harmful algal bloom. So that's why monitoring phosphorus is so important through time to understand, are we decreasing, are we stable, or are we increasing? As I mentioned in my previous presentation, is that phosphorus is used to calculate trophic status within our program, specifically summer phosphorus is. And so if you have under 10 parts per billion, you are oligotrophic, and as you increase your amount of phosphorus, you enter into either mesotrophic, eutrophic, and at a dramatic scale of hypereutrophic. In the CLMP, we collect in the springtime is an option, and the other option is to collect in the summer. In the spring, the timing is soon after ice off, and in the summer, it's at the height of stratification. We show it just like with Secchi disc. We say, like, so your year, you've collected one sample, and you have an average of 12 parts per billion, and then we compare it to your previous years, and then we compare it to other lakes within the CLMP and give you that graph through time. And we do that for both spring and summer. So why do we collect phosphorus in the spring and summer? So this goes back to our lake mixing. If any of you have heard of your lake is turning over or your lake is mixing, this is classically what's happening on our deep water lakes. So lakes over 15, 20 feet in Michigan, where when the ice comes off, the lake becomes fully mixed. That means the temperature is the same from the top to the bottom, but also everything else is mixed, including phosphorus. As the summer As the sun warms the surface of the water, it becomes less dense than the colder water below, and so it floats on top. This creates the thermocline that sits here in the metalimnion, and this acts as almost like a physical barrier between the top of the water to the bottom of the water. And so phosphorus, it changes as well, not just the temperature. So the phosphorus in the top of the water is many times different from the bottom of the water. And we're capturing this phosphorus during this stratification event. So what do our spring samples mean? So we collect within 2 weeks after ice out. I'm assuming some of you have had signed up, and I hope your arms have all thawed by now. But within 2 weeks after ice out is what we're saying there is within, when is ice out? Ice out is when the lake, it's safe enough that you're not having to push around any ice to get to the deepest part of the lake. During this time, the lake is fully mixed, so the phosphorus at the surface of the water is the same as the phosphorus near the bottom of the lake. It's representative, because it's fully mixed, of the whole water column. And this helps us understand the potential buildup of phosphorus within your lake. And you might get peaks every once in a while if there's certain circumstances within our weather. So let's say you have a big snowpack and then it rains 2 inches on top of it in the late spring. That can cause a huge pulse of phosphorus, but in general, it just helps us understand this long-term potential buildup within the system. Summer phosphorus is different because we now have this thermally stratified lake. So it's like a three-layer cake where the warm water is sitting on top of cold water, and we have this zone of transition. So the top is called the epilimnion, the middle layer, or maybe the raspberry filling layer, is the metalimnion, and then the bottom part of the cake is the hypolimnion. So at this point, we are still collecting at the surface of the water. Now it's only representing the top of the lake, the epilimnion. This helps us understand dynamics with summer algae, and we use this number to calculate trophic status for your lake. If there are, in a fully natural lake with not a lot of disturbance in its watershed or on its shoreline, oftentimes this number is much lower than the spring phosphorus. And if it's high, that could indicate that there's external loading. External loading is where there's phosphorus entering your lake from its watershed or from its shoreline. So let's jump right into the protocol and walk through much like what we did for SekiDisk. So first, what do you get in the mail? You get the monitoring instructions, you get your sampling and sample turn-in schedule and locations. And I'll talk a little bit more about that. But for example, when you collect your phosphorus bottle, you freeze it for a while, and then on our spring and summer phosphorus schedule, you have to, on a given day, send it in to us so that we can analyze it in time to keep the quality of the sample high. We give you the data form, we give you bottle labels, we'll give you 3 of them just in case you lose one, and we send you 250 ml sampling bottles that look like this. Here, I'll hold it against myself, like that. And the caps are on. If a cap is off, your bottle can be contaminated, and please let us know as soon as possible, and we will mail you some new ones. So the caps need to be on. One ends up being, so we send you 2. One is the actual sample, and the other one is a replicate. Because we like to do, we want to keep the quality of the data high, we analyze all actual samples, and then for a certain percentage of the samples collected within a given year, we do the replicate as well, and we compare them to one another. And that is to help us make sure that our quality continues to be high within the program. So other materials that are needed that you supply are a cooler bag, ice pack, Ziploc baggies of different sizes, and a pencil or a Sharpie. The pencil or Sharpie is an important note because if you write on the labels, for example, this is what a label looks like, and it's a pen that will run in water. You can imagine you dip it into the water and you lose everything that's written on there. A Sharpie and a pencil work nicely that won't run if it is written on a dry label. So spring phosphorus is measured during spring mixing. So that's within 14 days after ice out. So this means that depending on the latitude, it's different for each part of the state. So the southern part of the state is usually ice-free first, and they've already collected in March, whereas folks in the UP may not collect their spring phosphorus samples until May. I just talked with somebody who is about to go out in the next couple days to collect their sample in Cogebec County. The volunteer determines ice out. And this is really important. There's a part on the data sheet where you write down the date that is ice out. This makes sure that we know that you collected within that correct window. If you start to deviate away from 14 days, the comparability through time can be an issue because your lake can be starting to set up and stratify the further you are away from ice out. And so we like to maintain our quality at 14 days. It is a surface grab sample, and this shows nutrient enrichment trends through time. Summer phosphorus is measured during summer, the height of summer stratification, which is in August for UP lakes, and then for all other lakes in September. It depends on the latitude. So we give you the exact week to collect for your given county. It's also a surface grab sample at the deepest part of the lake, and it's used to calculate trophic status. So this is a phosphorus schedule. This is the summer phosphorus schedule for 2025. So if you've signed up for that, you will have gotten this in the mail. And so how do you read this is if you are a lake in Allegan County, you will need to turn in your frozen water bottle, a frozen water sample to this address. Here's a contact if you need to contact them for any reason. You can also contact me and I'm happy to help. This sampling dates column tells you if you're in Allegan County to sample your summer phosphorus between the dates of September 18th and 22nd. And then on September 23rd, you'll be turning in your sample between 8 and noon to this address. So we have it between 8 and noon. That's kind of a tight window, but what we do is we ship your frozen water samples to us so that we can process it further and get it ready for Eagle Laboratories to then analyze. And to keep the quality high, we need to ship it overnight so that they remain frozen until they get to us. Spring phosphorus, on the other hand, everybody turns in on June 24th between 8 and noon at your given location. So if you've, and there's a spring phosphorus sample collection and turn-in schedule that is also online or has been mailed to you if you signed up for that program or that parameter. So to the protocol, step 1, fill out the labels. As you all probably know and can imagine, if you put a label on your bottle and then dip it into water, and you're like, oh, I need to fill it out, with all those water droplets and the wetter now paper, it's not gonna work so well. So fill out your labels and stick them to the bottle before you sample using that permanent marker or pencil. And as you can see, we have 2 labels here. Put your initials, put the date that you're collecting it on, your field ID, that's that unique number that identifies your lake, your lake name, put GA in the analysis or parameter code, and then leave the chemicals added blank. Joe and I and others in our program will be adding acid to your sample to stabilize it, but we will write in there what we add. On the other label for your second bottle, everything is the same except in location, please write rep, R-E-P. That is indicating to us that that is your replicate sample. Step 2. So now that you have it all filled out, it is now time to go to the deepest part of your lake. Just like with Seki, we are going to drift into the deepest part of your lake. You don't have to be perfect, but we want you to be approximately over the deepest part of the lake. If you have to anchor, Drifting is important because if you resuspend sediments from the bottom and you collect that water sample, it'll be higher in phosphorus because sediment particles oftentimes have phosphorus bound to it, and it'll be analyzed that way. So we want to make sure we have a clean water sample to collect. What we'll do is remove the cap and rinse the water bottle down with lake water. So rinse it twice. So dump it out, put it in the water, swirl around, dump out. Remember, just use the bottles we provide. If you lose them or you don't get them, please contact us as soon as possible and we'll get them to you. Spring phosphorus has been mailed out already. If you've signed up for summer phosphorus, that doesn't get mailed out until the summer months. So no one should have them yet, but they will come out this summer. Make sure not to contaminate the bottle or the cap. So it can be easy, for example, to put your cap on the bottom of your boat, and then let's say it falls over into some mud that's on the bottom. We do not want to use that cap at that point. So make sure the cap stays clean and so does the bottle. Now to actually collect your sample, you've rinsed it out. You are holding the bottom upside down. So you hold the bottle like this and you hold then down and you put it in and you lower it into the lake around 1 to 2 feet deep, kind of elbow deep. Then you point it upward. And then as you can see in here, it goes bloop, 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 and it fills with water. Hold it until the bottle is full. And then bring it up, cap it immediately, and repeat with your second bottle. Now, because we are freezing your sample, if we froze it full, it would crack the bottle and it would be ruined. The sample would be ruined. And so dump out to be 3/4 full or so, and then cap it again. And so that will be enough space that allows the water to expand and not crack your bottle. Place your bottles in a labeled baggie and place in your cooler. So date, your lake name, and what it is. Fill out your data sheets, and please fill out as much as possible. It's really important to do that. And then fold it up and put into a separate baggie. And then what you're going to do is put that baggie with your samples so that they don't get disconnected. Oh, and it is very important to put your data sheet in a separate bag and making sure it's tight. If it's just put in with the water samples, it can get wet and either the ink can run or the paper shreds apart. Excuse me. Making sure that that is in a separate Ziploc bag is important. This is what your data form will look like. Fill out your lake name, everything, the field ID, the date of ice out being very important, and then when you sampled. Please fill out the back as much please fill out the back as well with a map and the approximate location that you sampled. Step 7, you're back on shore. Take it out of the cooler bag and store it in your freezer until the turn-in date. And on the turn-in date, which is on your phosphorus schedule, the drop-off location and time, turn in your frozen, making sure they still are frozen with your data forms to the designated location. So that's the protocol. And now I just want to go through some little tips and common reasons for sample rejection. The biggest thing is that the sample was collected at the wrong time. So for example, if you're in a lake in Berrien County and you wanted to do spring phosphorus, but you didn't collect within 2 weeks after ice off, instead you collect this week, we would be rejecting your sample. And so samples collected greater than 2 weeks after ice out will be flagged. If it's collected after 4 weeks, those samples will be rejected. For summer phosphorus, samples collected more than a week outside of its assigned interval week will be rejected. Sometimes there's incorrect delivery where if you can't turn in your sample on that given day, or something doesn't seem right and you just set it out on the sidewalk out in front of one of the designated locations without letting anyone know, those samples could be ruined and we will have to reject those. And then about the freezing. So if we receive a bottle that has been cracked, that's really unfortunate because now the sample can be contaminated and we will discard and reject that sample. So make sure you dump out some of that water so that before you freeze so that it doesn't crack the bottle. Also, the wrong bottles. So make sure you only use the bottles that we give you this year, and not anything else. If you lose them or you never got them, please contact us as soon as possible, and we'll send another set to you. Please do not use any other container. The reason why is that this Parmesan container or whatever container, won't be cleaned to the specifications of the lab, and it can be contaminated and skew the results of your water sample. And now talking about again, the showing of the value of long-term data, just like Seki. Here's a lake that has been collecting spring phosphorus since the early 90s and has been showing maybe a more declining trend, stable / declining trend through time. And that's so key to understand, well, how is our lake doing? Is it getting better? Is it staying the same? Is it getting worse? Having that long-term perspective is certainly helpful in answering that question. So before I'm done now, I'm going to share, or we're going to watch the video just to show it in a more real-time sense. And this, again, can be found on the MiCorps.net website.
Hi, my name is Tamara Lipsey, and I'm an aquatic biologist with the Michigan Department of Environment, Great Lakes, and Energy. Today, we're going to demonstrate how to take a phosphorus sample using the MiCorps Cooperative Lake Monitoring Program procedure. Phosphorus is an essential nutrient for plant and algae growth in lakes. In the Cooperative Lakes Monitoring Program, phosphorus is sampled in the spring, after ice out, and in the summer in August or September. Before heading out on your lake, please assemble the necessary equipment. You will need your 2 sample bottles that are provided by MiCorps, your labels, a pen and a permanent marker, your data sheet, a map of your lake, a cooler and ice pack, your safety equipment, and an anchor in case it's windy. Make sure you fill out your bottle labels and attach them to the bottles. It's very hard to write on bottles once they are wet. Let's take a look at what a correctly filled out sample label looks like. Please use a fine-tipped permanent black marker to fill out the sample labels. You will fill out your initials, the date, the lake name, and the lake ID number. In addition, write GA for parameter code. Leave the chemicals added area blank. You will do the same for the second sample label, but you will also write REP next to the lake name. This is short for replicate. Fill out the top of your data sheet and the map of the lake on the back of the data sheet. Next, proceed to your monitoring location, which should be over the deepest part of the lake. If you need to anchor, make sure you drop your anchor before the deepest location and then drift to your sample site. This will ensure you do not collect any sediments that might be suspended from the anchor. Once over the deepest location, unscrew the bottle and make sure to never touch the inside of the cap or bottle. Then rinse the bottle with lake water twice. Now grab the bottle around the base. Turn the bottle upside down and lower it into the lake about 1 foot below the surface. Tip the bottle upward to fill the bottle. Bring the bottle back up to the surface and spill out a small amount of the water so that the bottle is only 3/4 full. This will ensure the bottle will not crack when you freeze the sample. Store the bottle in your cooler with an ice pack and then collect your replicate sample the same way you collected your first. Once you're done with the replicate sample, store the bottles in the dark cooler with frozen ice pack and return to shore. Once you return to shore, you will need to freeze the water samples immediately. The samples go into a zip-top bag with your lake name, county, and field ID number. Fold the data sheet, place it into a separate zip-top bag so it stays dry, and place that in the bag with your samples. Storing your data sheet with the samples is a good way to make sure the paperwork never gets lost. Once you're done, store your samples in the freezer. On your designated turn-in date, deliver your frozen phosphorus samples and data sheet to the proper turn-in location. To learn more about the MiCorps Cooperative Lakes Monitoring Program, visit us at micorps.net.
All right. So there's our phosphorus protocol. Are there any questions?
I was able again to keep up on the couple of
Nice.
questions that came in, but since they're just in the chat and won't be in the recording, and we have a couple minutes, we could maybe talk about them again. So one person asked for clarification about whether it was too late to collect a spring sample.
And the answer is yes. For signing up, it's too late. So if you wanted to enroll, our enrollment deadline is in early spring, late winter. And for spring phosphorus, if you did enroll and you are in the UP, for example, and you still haven't collected your sample, it is not too late. It all depends on that ice out date. So if you're within 14 days, you have the bottles because you signed up for spring phosphorus, it's good to go. If you're in southern Michigan, yes, you are too late to collect spring phosphorus.
Right, another question that just came in. I see the data available in the data exchange and individual lake reports by county, but are there any available inferences of the cause of changes in the data?
So do we supply any of those? You're like, oh, there's changes in the watershed, for example. Is that the question, Joe? Is that
Yes, I think they're curious about interpretation.
Yeah, we provide the base data, and we do in the individual lake reports, there's some conversation and sentences about potential causes that could be out there. But no, we don't supply any of that within our program. You are more than welcome to contact our team, and we can have those discussions, and we might be able to link you with other data sets that are out there, or possible things to collect to gather to kind of make those inferences.
Great. And then another question that came in the chat during our conversation was just clarifying that after samples are collected, that those samples need to be hand delivered to a drop-off point. Could you reiterate that hand delivery process again?
Yeah, so you've collected your sample, they've been put into your freezer. And so they are frozen with all the stuff that you just saw, like the data sheets and whatnot. And now it's time to turn it in. You can, as an individual, drive to the location, the sample drop-off location, and you physically hand those samples in. If you would like, you might be in an area where there are a handful of CLMP volunteers, and you can work together and coordinate to maybe, let's say, I have tons of time and I'm heading over to Cadillac anyways, for example, and I can collect a bunch of people's samples, and then physically go to a drop-off location.